Okay, so mixtures, two or more substances physically combined. We have two types. We have homogeneous and we have heterogeneous. All right, so homogeneous, uniform, one phase. And what does that mean? I just like to put this in there. It's kind of like the layman's terms, meaning the simple way to explain it. Looks like one thing. I don't want to use the word substance because that'll confuse you, but it looks like you're looking at one thing. It looks like water, right? It looks like one thing. I don't see different pieces floating around in there. So uniform, one phase. That's what one phase means. There's only one part to it, right? Only one part. I should write that as well because I think that may help you. Heterogeneous, not uniform. Multiple phases. Looks like many things. More than one part. Okay, homogeneous here. Couple stars. I like my stars today. 3 stars. Cannot, underline, be filtered. Boiling, evaporating, melting, freezing, ... Any phase change, that's how we separate homogeneous. That's how we separate homogeneous, is by evaporating water or boiling it. Or if you have a mixture of liquids, you can freeze them. They'll freeze at different points. If you have a mixture of solids, you can melt them. They'll melt at different points. So you can separate them that way. So how to separate these phase changes, right? Distillation, Jake said. Distillation is a good one. Heterogeneous, how do we separate those? You can filter. Can filter. You can physically separate them. I'll put another star here. What does that mean? You can like pick them out with your hands. The different parts. Physically separate. That's not the best way to explain that, but I don't know how else to really word that without listing all the specific things. Because this is also physically separating, so that's pretty crappy way to write that. But the point is, big thing here, you cannot filter, you can filter. How do you separate this? You gotta heat it up, cool it down, something to do with boiling, melting, freezing, evaporating, okay? That's what the homework, I believe, is about, this type of stuff. Okay, let's list some examples, and that's gonna be it probably for today. All right, so you continue your list, I just need more room. All right, so homogeneous, the first one I'm gonna give you is salt water. Parentheses, put NaClAq. AQ means aqueous. When you see AQ, it means dissolved in water. I think I've already told you that, but I'm telling you again. You take two substances, salt and water, mix them evenly, uniform, you get salt water. AQ, that's what that means. Anything with an AQ means it's dissolved in water. Anything. I use that so much, you'll just learn it just by hearing it so many times. Heterogeneous, just use the one example there, one in the back. Italian dressing. Give me some more. Your turn, go. Think of food, that's the easiest way to go. Or things, you know, like outside or whatever. Dirt, which one? Heterogeneous, dirt, very good. Let's go, shout them out. What else? Sugar water. That's really funny. Makes me think of an old movie that I enjoyed from a long time ago. Makes me feel old, but Men in Black. Anyone ever see it? First one? Remember the part when you say sugar water? He turns into the bug. He's all messed up. He's like, sugar water. She's like, what's wrong with you? Anyways. What else?
Alcohol.
Which one?
Homogeneous.
Right. So alcohol. That could be a compound, but the stuff people drink, homogeneous. What else? Think about other food. What do you have in your fridge? Ice cream. What kind? Rocky Road ice cream. You don't have that in your fridge right now. Rocky Road ice cream. Any ice cream that isn't just straight up one flavor, right? Vanilla, chocolate, they would be, by themselves, would be homogeneous. But if you start mixing things, right, like mint chocolate chip, heterogeneous. Because some scoops might have more chocolate chips than others. What else? What about air? Air is a mixture. It's in this room. Can you see it? Can you see different parts to it? No, it's uniform. Air. Homogeneous. What else? Come on, give me a few more. Make sure you know this. Some of you are just staring blankly into space. Come on, I need help. Give me at least one more of each. Give me a heterogeneous, a food, something you eat or drink. Something you eat that is heterogeneous. It's literally almost everything you eat. What kind of soup? Chicken noodle, perfect. Good, I'm gonna give you one more here. Salt water with sand. I know that's really weird, but that's like what the Regents always talks about. You put some sand in that salt water, sand will never dissolve, so you can see it. Heterogeneous. Okay, homogeneous, I'm just going to give you one more. Milk should be, but maybe not. If you have whole milk, sometimes the fat, right, if there's still fat in it, then it will be separated, so that would be more like heterogeneous, but I'm just trying to get you to think. Ketchup, toothpaste, tomato soup would be homogeneous, right? Unless there's chunks of tomatoes. So I'm just trying to get you to understand the difference, all right? We're done. Bell's going to ring. Don't forget the bookwork. And Skylar, here we go. We're going to take a trip in the back. I'll show you these things. Say hi to Jake. All right, so the demonstration was Italian salad dressing. You can see the chunks in it. So that's heterogeneous. Salt water. There's salt water. Homogeneous. And you can separate heterogeneous with a filter. See, the solid stuff stays on top. The oil, water, vinegar would drip through. And homogeneous, I proved that if I pour salt water in here, it drips out here, so filtering does not work. We're going to evaporate the water. Salt will be left behind tomorrow, so I'll show you that tomorrow.